Good morning, my dear students. Welcome to the discussion on the subject Engineering Graphics. Under Engineering Graphics, we are going to discuss a topic on conic sections. Under conic sections, we'll discuss construction of ellipse by special methods. This is the 11th solved problem we are discussing under conic sections. Now we will enter into the problem. The problem which we are going to discuss now is very important, and it was asked many times under different university examinations. And also this problem is from NDBUT textbook exercise from conic sections. The given problem is two fixed points A and B are 100 mm apart. Trace the complete path of a point P moving in the same plane as that of A and B in such a way that the sum of its distances from A and B is always the same and equal to 125 mm. Name the curve. Draw another curve parallel to and 25 mm away from this curve. Before writing the data related to the given problem, first we need to recollect the definition of the ellipse. The ellipse is defined as a curve traced out by a point moving in the plane as and in such a way that the sum of its distances from two fixed points is always the same and is equal to the length of the major axis. Now we will understand the definition of the ellipse with the help of a drawing. Here AB is the length of the major axis, CD is the length of the minor axis. This is the elliptical curve. Then F1 and F2 are two fixed points. P is a point on the ellipse. Then sum of the distances of P from two fixed points, say Pf1 plus Pf2, and Q is another point on the ellipse. Then sum of the distances of Qf1 and Qf2, and C is a point on the ellipse. Then sum of the distances of Cf1 and Cf2 is equal to length of the major axis, which is equal to AB. Here P is a point on the curve. Then sum of its distance from two fixed points, say Pf1 plus Pf2 is equal to the length of the major axis, which is equal to AB. And also Qf1 plus Qf2 is equal to length of the major axis, which is equal to AB. And then Cf1 plus Cf2 is equal to length of the major axis, which is equal to AB. That is, ellipse is defined as a curve traced out by a point moving in the same plane as and in such a way that the sum of its distance from two fixed points is always the same and is equal to the length of the major axis. That is, here Pf1 plus Pf2 is equal to length of the major axis, that is AB. That is, sum of the distances of the point P from two fixed points, say Pf1 and Pf2 is equal to the length of the major axis, which is equal to AB. Here in the problem, it is mentioned that two fixed points A and B are 100 mm apart. Here A and B are the two fixed points. Generally in the case of ellipse, we used to mention fixed points as F1 as well as F2, whereas in the problem itself it is mentioned the fixed points as A and B. That's why we used the letters say A as well as B for fixed points. And also from the earlier discussion, we know that the length of the major axis as 125 mm. That is, here the ellipse definition is given in the problem. That is, trace the complete path of a point P moving in the same plane as that of A and B in such a way that the sum of its distances from A and B is always the same and equal to 125 mm. That is, the sum of the distances, say P2A plus P2B is equal to length of the major axis, which is equal to EF, which is equal to 125 mm, and also the sum of the distances of, say, G2A as well as G2B is equal to the length of the major axis, say EF, which is equal to 125 mm. That is, the sum of the distances of the point P from two fixed points, say A and B, that is P to A as well as P to B, is equal to length of the major axis, that is E to F, which is equal to 125 mm, and also the sum of the distances of G from two fixed points, say A to B, that is G to A plus G to B, is equal to length of the major axis, which is equal to EF, which is equal to 125 mm. With this fundamental concept of definition of ellipse, we will enter into the writing the data related to the given problem. Here, the name of the curve to be constructed is ellipse, and the distance between two fixed points, say A to B, is 100 mm, and length of the major axis, say E to F, is equal to 125 mm, and length of the minor axis is not given in the problem. Here, our objective is to construct the ellipse, and also we need to draw the curve parallel to the ellipse with a distance of 25 mm from it. Here, this is the inner ellipse and this one is the outer ellipse. The outer ellipse is at a distance, say 25 mm from the inner ellipse. For construction of the inner ellipse, there are different methods we can use, say arcs of circle method, oblong method, concentric circle method. But here we are going to use oblong method for construction of the inner ellipse, then we will draw outer ellipse. Next step is construction of ellipse by using oblong method, followed by drawing elliptical curve parallel to the ellipse with a distance of 25 mm.
Now we are going to construct the ellipse with the given data. In the problem, it is mentioned that the distance between two fixed points A and B is equal to 100 mm. So, with the given measurement, say 100 mm, draw a line AB. Now, draw a line AB with 100 mm length. Here, the fixed points are nothing but focus points. Generally, we used to mention focus points as F1 as well as F2. But here, in the problem itself, it is mentioned as A as well as B as fixed points. In the problem, the definition of the ellipse is given. That is, the ellipse is defined as it is a locus of a point moving in a plane in such a way that sum of its distance from two fixed points is always constant, which is equal to the length of the major axis, which is equal to 125 mm. Here, the major axis length is 125 mm. In order to draw the major axis, what we need to do? We need to extend the AB line leftward direction as well as rightward direction. After that, locate the midpoint of AB and name that point as O. After that, with O as a center, half of the major axis as a radius, draw an arc leftward direction on this line as well as rightward direction on this line in order to locate two ends of a major axis. Here the major axis length is 125 mm. Half of the major axis is 125 by 2, that is 62.5 mm as a radius. O as a center, draw an arc left side as well as right side of O along AB extended line and name the ends of a major axis as E as well as F. After that, we need to locate minor axis. For that, we will draw perpendicular bisector to EF line. the two ends of the minor axis points comes along this line. In order to locate minor axis end points, what we need to do? For that, we need to recollect the fundamentals again. Here, AB is the major axis, CD is the minor axis. Our objective is to locate the fixed points, say F1 as well as F2. For that, we will take half of the major axis, say OA as radius, and one end of the minor axis, maybe C or D as a center. Draw an arc on major axis, left side of O as well as right side of O, and name these points as F1, F2. Here the distance, say OA as well as OB is equal to half of the major axis, which is equal to CF1 distance as well as CF2 distance. That is, CF1 distance is equal to half of the major axis, CF2 distance is equal to half of the major axis, that is OA is equal to OB is equal to CF1 is equal to CF2, that is half of the major axis. With this basic information, in the present problem we are going to locate the two ends of a minor axis. Here CF1 distance is equal to half of the major axis. So take half of the major axis as a radius, that is OE as a radius, fixed point as a center, here A as the fixed point, that is F1 point in this case. Here we are naming it as A. Then draw an arc on the perpendicular bisector passing through O. That arc to be drawn above O as well as below O on the perpendicular bisector, and name these points as G as well as H. Here the distance, say GA is equal to OE, GB is equal to OE is equal to OF. Generally, the length of the major axis is mentioned as AB and minor axis is mentioned as CD, and fixed points are mentioned as F1 as well as F2. But in the present problem, the fixed points we mentioned it as AB, and major axis we are mentioning it as EF, and minor axis we are mentioning it as GH. With this basic information, we need to construct the ellipse. For construction of the ellipse, we have different methods, namely oblong method, arcs of circle method, concentric circle method. We can use any method. In the present case, we are going to use oblong method. In the case of oblong method, we need to construct the oblong with the given major axis length as well as minor axis length. For that, draw lines passing through E as well as F parallel to GH, and lines passing through G as well as H parallel to EF. Here PQRS is the oblong. With reference to this oblong, we are going to construct the ellipse. Regarding pencil usage, the major axis as well as minor axis are semi-dark, remaining construction lines are lighter. Here in the case of oblong method, we need to divide EP line into some number of equal divisions, and OE line also to be divided into same number of equal divisions. Similarly, OF line also to be divided into same number of equal divisions, and SF line also to be divided into same number of equal divisions. Here, if EP line is to be divided into required number of equal parts with scale directly, then we can divide directly with scale. Otherwise, we can divide EP line into equal number of parts by using the dividing a line into equal parts concept. Similarly, we'll apply the same principle for dividing the OE as well as OF as well as SF lines also. Here we are going to divide EP line into 4 equal parts by using dividing a line into equal parts concept. For that, draw acute angle line, then divide this acute angle line into 4 equal parts. That means I am going to divide this EP line into 4 equal parts. Then lose this knob on the drafter, then align the last division point on the acute angle line, then this point and P point to be aligned with the drafter. Tight this knob, join these 2 points parallel to this, passing through this point, draw a line. Similarly, draw another parallel line passing through this point, draw another parallel line, then name these points as say 1, 2, 3, 4. Similarly, divide SF line also into same number of equal divisions by using dividing a line into equal parts concept. Similarly, divide OE as well as OF lines also into same number of equal divisions by using dividing a line into equal parts concept. After that, join G2 1 points, G2 2 points, G2 3 points, G2 7 points, G2 6 points, G2 5 points. Here these lines are construction lines, so these lines are light lines, so these lines are drawn with 3H pencil. After that, join H2 1 point and extend this line towards G1 line. And name this point as P1. Similarly, join H2 2 points and extend towards G2 line and name this point as P2. Similarly, join H2 3 points and extend towards G3 line. Similarly, join H2 5 points and extend towards G5 line. Name this point as P5. Join H2 6 and extend towards G6 line. Join H2 7 and extend towards G7 line. Name this point as P7. Then passing through E, P1, P2, P3, G, P5, P6, P7 and F, draw smooth curve. This curve is nothing but half of the elliptical curve. Now we will draw this curve. After that, we'll draw remaining half of the ellipse. For that, we'll draw mirror images for the points, say P1, P2, P3, P4, P5, P6 and P7. For that, align the drafter scale along the major axis so that the scale is parallel to the minor axis. Then at P1, draw vertical line. At P2 also draw vertical line, that is the line is parallel to the minor axis. At P3 also draw vertical line. At P5 also draw vertical line. At P6 also draw vertical line. At P7 also draw vertical line. After that, from major axis to P1 distance as a radius, draw an arc on this vertical line. With that you will get P1 dash point. Similarly, from major axis to P2 point as a radius, draw an arc on this vertical line. With that you will get P2 dash. Similarly, from major axis to P3 point, draw an arc on this vertical line. With that you will get P3 dash. Similarly, repeat the procedure for locating P5 dash, P6 dash, P7 dash also. Then passing through E, P1 dash, P2 dash, P3 dash, H, P5 dash, P6 dash, P7 dash and F, draw smooth curve. Make a note, my dear students, while drawing the smooth curves, we need to hold the pencil little bit distance from the tip of the pencil, and also we should not hold the pencil tightly. We should not hold the pencil tightly. Now, dark this curve. With this we completed construction of ellipse by using oblong method with the given data. Then in the problem it is mentioned that draw another curve parallel to this curve with a distance of 25 mm. For that, take 25 mm as a radius and different points on this curve as a centers. Draw arcs. Say E as a center, 25 mm as a radius, draw an arc. Similarly, P1 as a center, 25 mm as a radius, draw an arc. P2 as a center, 25 mm as a radius, draw an arc. Similarly, repeat the procedure with same radius with different points on the curve. Drawing the arcs with a radius of 25 mm from the different points on the elliptical curve is completed. Locate points on the top of these arcs, then join these points with the help of a smooth curve. Now, dark this curve with H pencil. Now we will do the dimensioning. Related to the dimension details, here the distance between two fixed points say A and B is 100 mm and length of the major axis of an ellipse is 125 mm. The outer ellipse is with a distance of 25 mm from the inner ellipse. Here all the dimensions are in millimeters. Now we'll see the pencil usage details. Here the construction lines are drawn with 3H pencil. That means those lines are lighter lines, whereas length of the major axis as well as length of the minor axis lines are drawn with 2H pencil. That means those lines are semi-dark, and the dimension lines are also drawn with 2H pencil. That means these lines are also semi-dark, whereas these two elliptical curves are drawn with H pencil. That means the elliptical curves are dark curves. Generally, in the case of ellipse, we use the letters say F1 as well as F2 for fixed points. Those are nothing but focus points. But in this problem, the problem itself, it is mentioned that the fixed points names as AB. With that, we used major axis name as F and minor axis name as GH. This is a ND Butt textbook exercise problem, and also this problem was asked many times under different university examinations. With this, I am asking you to practice perfectly from beginning to the ending in order to score good marks in the examination.
If you have any queries or doubts related to the present solved problem, you can mention it under comment section of this video. I'm happy to answer it as quickly as possible. For more videos on engineering graphics, visit the links provided under description of this video. Keep learning on knowledge sharing. Stay blessed. Thank you.